Hello and welcome back to On the Brink. I'm Nick Carter. Today we sit down with Jon Cole and Asa Oines of the Abacus Network, a project devoted to cross-chain interoperability with a focus on applications. We talk about their career trajectories to date and why they decided to leave Galaxy and CeeLo respectively to start Abacus, the three eras of interoperability, the move from asset-based interoperability to app-based, and what the advantages of app-based interoperability might be, the problems with creating derivative assets on chains, and the challenges that we've seen in terms of blockchain applications fragmenting liquidity across chains as they try and duplicate themselves across chains. We go into much more detail in the episode. Let's dive right into it. Hello, gentlemen. Sitting here with Jon Cole and Asa Oines of Abacus. Asa, it's your first podcast, I've been told. Thank you for joining us.
You've been told correctly. It's very exciting to be here. Thanks for having us.
Yeah, good to see you, Nick.
Thank you, Jon. There's actually a number of guests. We've done like 300 episodes of this podcast, which is crazy. There's a whole bunch of people who chose us for their first podcast, so we're honored that you selected us. Let's jump into it. Let's take it in turn. We'll start with you, Jon. Tell us a little bit about your career. A lot of our listeners will know you, of course. And what led you to Abacus?
Thanks, Nick. So I spent the last 5 years investing in crypto in various capacities. Before that, and actually during those initial periods, I was a bond trader at Morgan Stanley, which is a funny, vocation for someone who has a strong distaste for banks of all kinds. I've had terrible experiences with banks since I was a teenager, growing up in Israel, where the banks are notoriously unpleasant and you really don't want to deal with them if you don't have to. Then had the luck or misfortune, you could say, of being one of those Wells Fargo clients who got ripped off in the big account scandal. But leaving school, Morgan Stanley was one of the few places where I could make the living that I needed to support my family. So it was a good choice. And a trading desk is a really fun place to be. It's a high energy environment and it's an intense workspace, which is kind of what I was looking for. And I found crypto right around the same time when I started there in 2016 and very quickly became the laughing stock of the desk for being the crazy guy who's into this weird coins thing and has computers that mine stuff, which, mind you, a bunch of fixed income traders could not wrap their head around, no matter how many times I tried to explain it. And at some point became obsessed with the idea of just working and helping support this industry. And so my time in Morgan Stanley became numbered. And told my boss, hey, I'm gonna take the first opportunity I can to get into crypto full time. That happened in late 2017. Joined a firm called Passport Capital. Became one of the venture investors there. Had a good run there, and before you know it, time passed, and I had the opportunity to join Galaxy Digital, where me and my partner at the time, Michael Jordan, built the investment team. Ran it for the next 3 years until meeting Asa and the bunch, and very quickly became convinced that I want to move on to working on Abacus. And you asked, like, what made me want to work on it? So in 5 years of investing in crypto, I'd spent a ton of time thinking of interoperability, because the moment you grok the idea of like these internet computers, these decentralized clouds that blockchains can be, you're like, wait, why don't they talk to each other? Why if I'm on one of them, why can't I just move over to another one? That seems really, it's very unintuitive that this would be the case. But once you get, that's kind of like there's this Dunning-Kruger peak where like you don't know what you don't know and you don't understand enough about how these systems work. And you're like, interoperability is going to happen any day now. And you don't understand why it is the case that the systems can't natively communicate with each other. And you don't appreciate the difficulty in that. And with time, I learned, like, wait, this is a non-trivial task. I used to liken it to the crypto equivalent of going to the moon from the difficulty of the engineering task. And meeting Asa, meeting Nam, the rest of the team here was the first time that I felt like, you know what, we should choose to go to the moon, because like in this case, we have the design, we have the capability to actually do it. And it took a little bit of thinking on mine and some persuasion, but it didn't take that long. And very quickly, I was like, "Shit, I have to do this," and dove head first.
All right. Asa, what about yourself?
Yeah, I grew up in. You asked for a career, but I'm gonna take you all the way back. I grew up in Watertown, Massachusetts. Nobody knows it, but it happens to be neighbor the far more famous Cambridge, Massachusetts. And as a junior in high school, I had the good fortune to find myself interning at the MIT Media Lab on a PhD thesis project for Ara Kanayan, in case he's gotten into crypto in the last, I don't know how many years. Working on a reconfigurable robot using electropermanent stepper motors. And we didn't have a computer science program at my high school. And so this was really my first exposure to this world. And I absolutely fell in love. Spent as much time there as I could, quit all of my sports. I wasn't very good at them anyways. The subways and public transportation, I believe, stops running on weekends at 2 a.m. And I found myself missing that pretty frequently and walking, the 3 or 4 miles home back to my house just in order to spend like a little bit more time at the lab. And so from that point on, I was pretty convinced that this industry, computers generally is kind of what I wanted to devote my life to. So I spent the next 5 years at MIT as an undergrad and then doing my master's, the latter of which I studied under Sepp Kamvar, who would later go on to found Cello. Spent 3 years after school at Google doing machine learning research, specifically acoustic modeling for speech recognition. And then Sepp, with whom I had stayed in touch, kind of been a mentor to me since I first started studying under him. He had always been pushing me to do something more entrepreneurial than join I think at the time, at least 100,000 person company, maybe 200,000 people. Probably the least entrepreneurial thing you can do coming out of MIT. And in 2017, kind of during that bull market, right when everybody was, a lot of the world was getting into crypto for the first time, Sepp started reaching out to me and saying, hey, I think there's something really interesting here. You should start learning about it. And in particular, he pointed me to some of the work on natural capital-backed currencies and how crypto was maybe the first opportunity to actually try this out in the real world, right? It was an idea that had been around for a while, but the technology to make it possible just didn't really exist. And crypto, and in particular, Ethereum, was the first technology that would maybe allow for something like this to be possible. So I thought that was a really inspiring idea. It's kind of the first thing that I've had ever heard of that seemed like a solution to the root cause of some of our kind of climate and pollution issues rather than, treating the symptoms, right? More kind of Band-Aids. And so when Sepp and Merrick and Renee were starting Cello later that year, it's kind of a natural kind of decision for me to join that project. And I spent about 4 years there leading protocol engineering, where I designed and helped build things like the stablecoin protocol, consensus, proof of stake, kind of a broad array of things. And then kind of towards the end of that, started, I really thrive off of greenfield work. And obviously 4 years in, kind of start to lose that aspect of things. And so kind of looking at the optics protocol, which was developed at C Labs, saw an opportunity for the opportunity to do more greenfield work, and thought there was an interesting direction that we could take it in focusing on kind of app first and app centric interoperability, as opposed to kind of ecosystem wide, or like ecosystem first interoperability or asset first interoperability, which I think to date has been the focus of a lot of interoperability projects.
Yeah, it's a great segue there. So, I think you guys define it as there being 3 eras of interop. First, sort of, kind of walled garden-ish almost, where, it's interop, but within this sort of defined rule set, and you have to kind of play by the rules of the one protocol. So, I don't know how much interop that, truly gives you. But it's interesting because I think Polkadot is kind of emblematic of that. But they're just now sort of getting up and running. So it's almost like we're still learning about that era.
Yeah.
And I mean, are we still in the first era of interop with sort of Cosmos and Polkadot?
We might be in parallel in all 3 of those eras. So to give the audience some context, so we think of there being 3 eras of interoperability. The first one looks like more of these, as Nick said, right? These defined rule sets. You could think of Cosmos Cosmos and IBC really being a beautiful example of that. Polkadot in Substrate, a similar one, where the system gives you a toolkit, and it says as long as you're within these bounds, in IBC it's if you have fast finality and a light client, if you're a parachain in the Polkadot world, you can have great interoperability within the confines of the system. Then, as you said, Nick, that area is still kind of playing out today as these things take a long time to build, and they take a longer time to scale. So what started as designs from probably 6 or so years ago are now starting to come into fruition. But from then on, we moved into another era, and it's fair to say these are all parallel processed. But
Right.
Starting kind of in 2019, you started to see this asset-focused interoperability, which is a lot of the bridges that we see today that lots of people use. And the idea is like, hey, I want to get this asset from this chain to that chain. I have some Ethereum. I'd love to take it to Solana, or I have some USDC, but I have it on ETH, and I'm dying to take it to Polygon. And that was guided mostly by the needs of the power users of the last couple of years, which have been trading firms, right? If you're Jump, if you're Alameda, they were active on all these chains, and they needed to move those assets there, and they needed to move there fast, and they needed to move it securely. Of course, this met the needs of many users, and that's why these bridges are very, very popular. But we think it's time to move into this third era, which is app-focused interoperability. And really why that paradigm is much more interesting to us is, if you think of what the bridge allowed you to do, it allowed you, the user, to go to the app, but we want to help the app come to you, the user. And so how can we make it where your application can really share state between a bunch of blockchains, and where your total applicable market, or your TAM now gets to expand beyond the chain that you happen to choose on.
And just returning briefly to the asset interop era, I mean, how do you judge the success of that era? I mean, obviously there's high profile hacks there. Was that sort of a functional model, or was that just a transitional phase?
So obviously we're biased. We're inclined to think it is a transitional phase because it solved this immediate need. The bridges as they're constructed very much fit that mold of being a painkiller, because someone desperately needed to move assets from chain to chain, and they couldn't think of a better way to do it that didn't involve swapping through a centralized exchange. And it works really well until it doesn't, as we've seen from some of these breach events. But really, the main issue that we see with the bridges is it's not so much the security incidents, although those obviously are very important. Like the two largest recent security incidents are not necessarily the result of like the bad security of the bridges. One in Ronin was an operational security on the bridge operators, unfortunate. And the other in Wormhole, again, was it was kind of a code error, and the fact that um, the pull request was submitted but not merged for some amount of time that probably allowed the hacker or the attacker, let's call them, to figure out that there is some attack surface that can be, but the network actually operated as intended. It just, that bit of code was the issue. And so really the problem that we see with bridges is not just the security, it's the fact that they create this very unpleasant fragmentation because each bridge is going to output a different asset. And so that's how we end up now with, say 15 forms of tether on a chain like Solana, because each bridge now tells you, oh, my representation will win. And now we have this token representation war, which is really to the benefit of no one. It's hard to think who really benefits from this. And so with Abacus, we think we're actually allowing a single issuer to create their token in a multi-chain fashion, kind of natively. So that's our opinion about that. But certainly if you spoke to someone else, I'm sure they would be more supportive of that bridge model.
And maybe to expand on that just a little bit, for some color for the audience, in case they're kind of not familiar with how these things work under the hood. Token bridges typically do not actually, I guess, move the token from chain A to chain B. What they really do is you as the user give them your token and they will issue a derivative for you on a different chain. And so all of these bridges are issuing slightly different derivatives. And so again, you're not really moving the token. It's just you're asking yourself kind of when you decide to use one bridge or another, it's like, whose derivative would I prefer to have on this destination chain? And it's not actually kind of the underlying asset.
So in terms of application first, interoperability, I mean, there are applications that are parallelized on different blockchains. They're not exactly, I wouldn't consider that shared state, but you'll have the same application being sort of mirrored or duplicated across chains. What's it going to look and feel like to have an application that's sort of natively cross-chain?
Yeah, no, that's a great point, Nick. So the model that we've seen for taking applications cross-chain thus far has been exactly as you said, a model of duplication, where you take the same code. Let's say you start by launching your app on Ethereum, for example, and you want to launch on Polygon. You take the exact same code that you've deployed on Ethereum and you deploy it again on Polygon. And now you have two entirely separate instances of your app running on two entirely separate networks. And the thing that really connects them is in their functionality, right? So they're doing the same things, even though they're not touching each other in any way, they do the same things, and in their brand. So, assuming it's kind of the same like entity that's kind of associated with both of these deployments, you might get the same, you might be able to visit the same website and click a drop down and get to choose kind of which of these two parallel deployments you're interacting with. There's a big drawback to this approach, which is that when you have two entirely separate instances of this app, they don't benefit from the existence of another. So imagine you kind of had initially launched on Ethereum, and say you're a lending app, for example. You launch on Ethereum, you do all this work to kind of build up, say, $1 billion in TVL, right? And each additional dollar that you're getting in TVL makes the application more usable, right? The kind of cost to borrow goes down, the available assets for people to borrow goes down. Um, you know, most of these protocols have very strong network effects. When you launch your app on a new chain, an entirely separate instance, you don't benefit at all from all of the work that has gone into building these network effects on, in this example, on Ethereum. In a world where you have truly app-centric interoperability, because those applications are able to share states, either through Abacus or some other kind of cross-chain messaging protocol, you can kind of think of those two applications as one. You're just now reaching, it's not two applications as one, you're just reaching a new set of users, a new set of assets, and becoming interoperable with a new set of protocols. And so rather than starting from square zero with respect to your network effects, in many cases that's TVL, you bring all of those network effects with you as you go out and reach new users, new assets, and new protocols.
So from the perspective of a user, you could envision a model where they interact with the application. It's sort of irrelevant to them which blockchain or protocol the settlement occurs on.
Exactly. I think in this model, at least in kind of the near to medium term, the only thing that the user would really need to know about with respect to kind of the underlying blockchain comes from when they need to sign a transaction, right? They're interacting with that application. They're interacting with a concrete instantiation of that application on a particular chain. But that doesn't limit them from accessing the utility that application has on any other chain. So they just need to kind of select the right network in MetaMask or what have you. And that's kind of the extent to which, again, this underlying infrastructure would need to be exposed to them.
And for the developers, aside from the network effect benefit of having liquidity, across blockchains, what are other reasons why it would be prudent to build, natively cross-chain?
It's a good question, right? So the first and foremost one is you're a developer in crypto. Now you have to ask to yourself before you get started really is which chain am I going to build on? Which is also saying which chain am I going to hitch my wagon to and tie my fate to? And if you think about it, why does this question matter? Because, as we said before, there are massive implications to the platform that you choose. And beyond just things like uptime, availability, resource costs, you're also limited to the usership that exists on that chain. And so you can imagine one reason why someone might find it prudent to build in this manner is that now they increase their potential usership because it's no longer limited to that first chain they started with. But also, if they happen to make, so to speak, the wrong choice in their initial blockchain, they did not doom their business. And so in a way, they're removing a measure of risk that was kind of extrinsic to their operation to begin with, right? What if you happened to build on a certain blockchain, let's say the XYZ blockchain, but turns out that no one cares about it. The community never galvanized around it, and there's just no one there. And so you may have built the world's most interesting product, but there's no one there to see it. And so that's a big reason we think why developers will be interested in a platform like Abacus. And if you've already had a certain app, especially if one you've deployed in a cross-chain fashion, but again, in this instanced, the apps all share the same name, same brand, but don't share state, you might want to do it simply because you're now reinforcing a lost network effect. Like your original reason to deploy on other chains clearly was you wanted to access more users. Now you actually get to connect them in a way that benefits each one of them, where you didn't have that before. And so those are some of the things that we think will be attractive to any developer looking at Abacus or something like it.
So the history of cross-chain is kind of fraught, I would say. There haven't been too many. Yeah, I mean, I remember back in the days when people were excited about atomic swaps between Bitcoin and
Don't
Litecoin,
we remember? Yeah,
SPV swaps and things like that. But it hasn't necessarily been a space that's covered itself in glory historically. So curious to just get into the sort of nuts and bolts of how Abacus works, and how specifically you actually make blockchains communicate with each other.
For sure. One thing before we even get really into the nitty gritty of the architecture, like this is fraught with risk. Blockchains don't know anything about data from the outside world. That includes other blockchains. And that has been one of the hardest problems. This is why earlier I likened it to the crypto equivalent of going to the moon. It's a very non-trivial task. And so when we're sitting here in 2022 and someone's like, why doesn't this stuff exist? Like why when it does exist, it has all these issues, and why doesn't exist in the way that they're talking about it? It's because it is incredibly, incredibly hard. You need to be able to ensure that one blockchain can know something about the outside world. In this case, it happens to be something that happened on another chain, and you need to do that securely. But to have a strong developer product, you also need to do that in a way that is sufficiently fast and easy enough for them to work with, right? Like they can't all be rocket scientists. And so with that, I'll let Asa do the honor of telling everyone a little bit more about how Abacus actually works.
Yeah, that would be my pleasure. So the way Abacus works is that there are two contracts on every chain. There is an outbox contract that is responsible for ferrying messages from that chain to all the other Abacus supported chains. And there is an inbox contract that is responsible for delivering inbound messages that are coming from the other chains to their intended recipient on this chain. Most of the magic, I guess, or most of the complexity is in how messages make it from the outbox to an inbox. And I'm going to get to that, but I'm going to first start with just talking about the kind of interface that you would interact with as a developer with these kind of inbox and outbox contracts. So if you want to send a message to a remote chain, you call a function on the outbox contract on your chain with the data that you would like to send, so an arbitrary byte string, as well as the destination chain ID and the address of the recipient on that remote chain. These three values, along with the sender address of the message and the source chain ID that the message is coming from, are hashed and inserted into an incremental Merkle tree, which is stored in the outbox smart contract. So that's the same data structure that the ETH2 deposit contract uses. It's an append-only Merkle tree that allows for very efficient insertions into the tree. After that data is inserted, a new Merkle root for that Merkle tree is calculated, and the Abacus validator set is responsible for signing the Merkle root so that the signature on the Merkle root can be verified by an inbox on a remote chain. And like I said before, I'll come back to exactly how the validator set works. After the inbox has verified that a quorum of validators has signed the Merkle root, that message that was inserted into the tree in kind of step one can be proved against that root and dispatched to the intended recipient. And so as a developer, to integrate with Abacus, all you need to do is you need to define a function that will call a function on the outbox contract with, again, the data that you want to send and who you want to send it to. And then you need to define a function that will accept function calls from the inbox contract on your chain when there is a new message being sent from a remote chain to you. And that's it.
So Abacus is not a blockchain in its own right. How would you describe it?
Yeah, that's exactly right. Abacus is not a blockchain. It's a network between blockchains. And maybe this is a good opportunity to talk about the Abacus validator set and what's really going on behind the scenes. Because again, I guess anybody can create an API and kind of claim that it kind of can be used to ferry messages from one chain to another. But obviously, how that is actually achieved is the most important part. So, Abacus implements a proof-of-stake protocol entirely in smart contracts that is deployed to every blockchain that Abacus supports. That proof-of-stake protocol functions a lot like proof-of-stake protocols you might be familiar with from your kind of favorite proof-of-stake L1s. The ABC token is used to stake, is used as a staking token in order to elect a validator set. And again, it's these validators that are responsible for observing the outbox contract and signing new Merkle roots as they are created when applications send new messages to the outbox. The nice thing about this is that by having the stake that is used to secure the validator set live on the same chain as the messages that are being sent, Abacus is actually able to permissionlessly allow for slashing when validators behave fraudulently, right? So you can kind of think of Abacus and the Abacus validators as an Oracle network responsible for moving Merkle roots from chain A to chain B. But unlike Oracle networks that you may be used to thinking about, that are responsible for reporting kind of fully exogenous information to a chain, like what is the temperature in Miami today?
Hot.
I'm sure it's hot. I don't want to know the answer. That information, there's nothing intrinsic to any chain that can reason about the answer it's being told, right? All the chain can do, or all a smart contract can do, is look at like who is telling me this information. The nice thing about oracleizing data that lives on a chain is that chain knows what the answer is. And so by homing the stake in the same place as the source chain, by homing the stake on the same chain as where messages are sent, if validators try to sign a root that does not correspond to the true history of messages, the outbox contract is able to very easily, check that signature, see that it was a signature on a root that it has never seen before, and slash the validators. And so unlike kind of many other Oracle networks, you're able to offer a level of economic security and make the statement that if there is fraud, it can be detected by anybody, and anybody can present that fraud in order to punish the validators.
So what are the sort of key assumptions? What do you have to believe in order to trust that the network will function the way it's intended to?
In order to believe that the network will function as it's intended to, it's helpful to think about the kind of the properties of proof of stake and what kind of economic security means for a proof of stake protocol. So in a proof of stake protocol, the economic security is the difference in size between, the stick and the carrot, right? So the stick in this case is what can the protocol dole out as punishment to a Byzantine actor, so a fraudulent validator. And the carrot is what can that fraudulent validator get away with if their kind of attack on the network is successful. And to have positive economic security, you want the stick to be greater than the carrot. Now, if you look at this kind of framework, if you kind of look at layer ones through the lens of this framework, I think kind of anecdotally we've seen that the stick does tend to be larger than the carrot, right? The stick is just the total value at stake, whereas the carrot is, I guess, the reward that you could potentially get away with if you were to either fork the network or censor or otherwise reorder transactions. And I think the important thing here to note is that Byzantine validators, even a Byzantine quorum of validators, do not have full control over the state of the network. They can only apply valid transactions that they are aware of or that they have the ability to create, by signing with their own private keys. But if I control a Byzantine quorum of validators, say on Cosmos, I have no control over your atoms. Now, if you look at proof of stake being used to secure an Oracle network like Abacus, you actually, it actually looks a little bit different. The stick looks the same, right? Which is, there's a staking token and kind of the amount that can, the size of the punishment is just relative to the size or the market cap of the staking token. But the carrot, which is, again, what a Byzantine quorum of validators can, I guess, steal through misbehavior, looks very different because on the destination chain, there is no way to intrinsically verify what the validators are telling you. In other words, the validators have much more control over the state in an Oracle network than validators do in a layer one. Because in a layer one, you have this state transition function that verifies that transactions are well formed, whereas in an Oracle network, you are somewhat beholden to kind of whatever the validators are telling you. And so this is why we believe that proof of stake for something like Abacus is a good start, but it's not actually the whole story. And so we look at kind of proof of stake as addressing economic security first and reputational security second, right? So economic security, I hope, is, kind of straightforward at this point. It's just, again, the difference between the stick and the carrot. Reputational security is a little bit more nuanced in that, a lot of the actors that participate in these systems have something to lose more than the tokens they staked, right? They've built a business on being known as kind of trustworthy, high uptime, reliable actors. And that's actually very valuable to them. I think a lot more than maybe a lot of people give credit to. Obviously, it's difficult to put a concrete number to. But if you look at something like Wormhole, right? Wormhole, I believe, is it 17 or 19 guardians?
19, yeah.
19 guardians, kind of, I think, carefully vetted by the folks that kind of run that network. There are no protocol level incentives for good behavior. And similarly, there are no protocol level disincentives for bad behavior. And I think last I checked, there's around $3 billion in kind of TVL locked up in the Wormhole token bridge. And from a technical perspective, there's nothing stopping those 19 validators from colluding to kind of, I guess, rug all $3 billion in TVL. And so I would say that when you analyze that system from an economic security perspective, there's negative $3 billion of economic security. What's harder to put a number on is the reputational security. But I think probably everybody here and most folks listening wouldn't feel that uncomfortable moving tokens over wormhole, at least from the perspective of, am I worried that these 19 folks are going to collude together and rug me, right? Probably not. And why is that? Because collectively, the value of their kind of reputation and their brand to them kind of clearly exceeds, I guess, what they could get away with by, again, trying to subvert the system. And so while you can't put a number on reputational security, I just want to underscore that it is very valuable. All of that said, I know I've been talking for a while here. Again, proof of stake is just one, and the economic security that it provides and the reputational security that it provides in having known actors participating in that proof of stake protocol is just one component of the security model for Abacus. As we've talked about kind of during this podcast, Abacus is very much focused on application-centric interoperability. And so I guess in keeping with that vision, we have a protocol that we call sovereign consensus that complements proof of stake, that is very much in the kind of application-specific lens of security. The way sovereign consensus works is it is essentially a before hook into message processing that applications that integrate with Abacus can optionally specify arbitrary rules around what sorts of messages they want to receive and what sorts of messages they want to reject, and the conditions in which they will accept and reject messages. Obviously, you could just build that. You might think, I guess, obviously, you could just build that into my application smart contract. But there is some, I guess, difference between putting these rules directly in the smart contract versus sovereign consensus, which is that Abacus will both present you with the metadata around, I guess, how was this message moved from chain A to chain B, right? Who signed it? What routes, or rather, what route is it being proved against? And it will allow whoever is proving that message against the route to include arbitrary data that the application's sovereign consensus module can consume. And this allows for kind of a really, I guess, flexible, This allows for applications to specify kind of really flexible rules around kind of what messages they want to accept or reject. So for example, one thing you could build, and we will provide a reference implementation for, as well as a reference deployment for, is this concept of sovereign guardians, where in addition to a quorum of validators, Abacus validators, being required to sign off on a route before messages can be proved against it, you also require some entities, presumably incentive-aligned entities, nominated by the governance system of your application, be it a DAO, a multi-sig, some guy with a ledger. You require that those parties also sign off on that route. And that does two things. First, it brings quite a bit of reputational security from the application into the Abacus system. Because now, if there's going to be a safety failure that affects that application, not only would the Abacus validator set need to be compromised, but you would also need the guardians that application is running to be compromised as well. And I think, again, kind of coming back to reputational security, I think a lot of us would feel, coming back to reputational security, I think most folks would expect that the application that they're interacting with is not trying to rug them. Secondly, it isolates failures. So, God forbid, there is some kind of quorum-sized compromise of the Abacus validator set. So long as those sovereign guardians aren't compromised as well, all the applications that integrate with Abacus will remain safe. I think the last thing to note here is that this is actually not much of a change from the existing trust assumptions you make when you interact with an application. If I go and I, use Uniswap, for example, um, realistically, like maybe I've read the smart contracts, maybe I've checked that they're verified, but even if they're verified, even if I'm checking that they're verified, I'm trusting that the block explorer attesting to their verification is telling me the truth. Maybe I compile them myself and compare the bytecode on chain. Even if I do all of that, as soon as I start to use the UI, I am trusting that the folks that implemented the UI, in other words, the kind of stewards of the application, have implemented the UI in a way that is signing a transaction that I'm actually intending to make, right? So no matter how you, like which way you kind of slice it, at some point you are placing, when you use a decentralized application, at some point you're placing a good amount of trust in the application itself. And I think this concept of sovereign consensus, and specifically in sovereign guardians, really leans into that.
We talk about this a lot, but to continue like what Asa was saying, it takes what is an implicit ask for you to trust the app. If like it's not even just the UI, right? If the contracts are upgradable, you're trusting that they're not going to flip the rules on you after you started engaging, and they make it. Sovereign consensus can make that ask explicit. You could say, basically, tell your users as the app developer, hey, this time around, because we run the sovereign consensus on our own app, if you're getting rugged here, we're in on it. Of course, we're not going to do that because that basically makes us a criminal enterprise. Uh, and so now you get that added measure of confidence, where if you really think, especially in financial applications, they're all built on trust. Almost every fintech out there, its brand, all of its defensibility is built on trust. And so we think for a lot of developers, this idea of making the trust ask explicit if they want to is going to be a huge point of appeal.
So, in terms of the other, this new generation of cross-chain focused application first interoperability protocols, how do you distinguish yourselves from these other?
Number of ways that we do that, and we could get into the technical differences, but beyond the technical differences, which are certainly meaningful and we believe will be valued by developers, for us, with Abacus, the key things we're focused on are both the simplicity and the speed of the system. And the simplicity will touch on just what is it like to integrate it. Is it limited to folks who are on the far right edge of the talent distribution, or can it be accessed by some moron like myself? And the goal is certainly to make it much more accessible to think of it like a developer of any talent level. So it's not just that, as we call them in crypto, the giga brains are the only ones who can leverage it. And then again, when you think of speed to us means two things. Speed is not just how fast can these messages be transmitted securely, which is very, very important. But it's also the speed from you going from barely knowing about what Abacus is to being able to launch your Abacus app. And we're hell-bent on making Abacus a very short, we have an internal metric like the time to success, right? We're very adamant about that being no longer than the time frame of a weekend. Abacus should be something that you can very quickly go from 0 to 100 on. And of course, then there are the technical differences, which depending on whatever you're comping it to, whether it's Axelar, whether it's Layer0, whether it's Nomad, those are going to be different each time. But so I guess in architecture, we're probably the most similar to Nomad. So maybe we start with them. Key difference is that in our security model, which they use an optimistic system, which can be incredible for a number of things. And we just don't believe that it's the best way to achieve this shared state. That was what the experience we desire to give our developers. Am I missing anything insofar as the?
There is kind of, I guess, a nuance in the efficiency in which roots, or talk a lot about roots, but when I'm saying roots, in the end, the effect of what I'm saying is messages. There's a nuance in how kind of messages are transmitted from one chain to another that allows Abacus to, I guess, move messages more efficiently than in Nomad. In Nomad, I believe, kind of with the update model, every update. So this may go over the head of anybody who's not kind of familiar with how it works, but basically, I guess every time you want to move messages from, say, chain A to chain B, you're also creating an operation that needs to be done on, say, chain C. That's in the Nomad model. Whereas in Abacus, if you want to move messages from chain A to chain B, you only need to do operations on chain A and chain B.
And then maybe worth getting into Layer0 and Axelar.
Yeah. Let's cover those two, especially Layer0. It's the one that people are very excited about these days.
Yeah, and for good reason, right? I think kind of all the excitement around Layer0 really speaks to the excitement around kind of app-centric interoperability. And so we're very encouraged to see, I guess, all of the buzz that their launch and their product has created. When you think about kind of, I guess, Abacus as it relates to Layer0, I think high level, the biggest difference is in security model. There are more kind of nuanced technical differences in exactly kind of what is being communicated. I think Layer0 is focused on moving block headers, whereas Abacus is focused on moving these Merkle roots, which are kind of internal to smart contracts, and that results in kind of I guess, different trade-offs in terms of how quickly these protocols can be expanded to other chains, the cost of proving state kind of against either in Abacus, the outbox Merkle root, in Layer0, the kind of block header state Merkle root. But I think, again, the biggest difference is in security model. As I described before, Abacus is uses a proof of stake security model, which allows or basically ensures that if validators misbehave and act fraudulently, they are certain to be slashed because, again, the stake lives in the same place as the knowledge of the source of truth. Layer0, as I understand it, really provides a framework for security, which is, I believe they have two roles, the oracle and the relayer. The oracle is a permissioned entity that signs block headers, and the relayer is a permissioned entity that proves state against the Merkle root in that block header. And I think they make the argument that so long as these entities don't collude, you can never wind up, relaying state to a destination that wasn't actually valid on the source chain. But, of course, the onus is on the developer to integrating Layer0 to decide, who is going to be my oracle, who is going to be my relayer. And we think that, that's a really important question, right? Because as we've kind of talked about in the beginning of the podcast, cross-chain communication is fraught with, examples of things going horrendously wrong, right? And the oracle and the relayer together have the power to make things go very smoothly or as wrong as you could possibly imagine. And so I think the big difference there is in that Abacus kind of gives you a decentralized network of validators that will help you move messages from A to B out of the box. if you want to layer on sovereign consensus on top of that, obviously that is that is kind of up to the application. It can provide an additional layer of security that we think will be appreciated by more mature applications, but maybe not interesting to applications that are just getting started that maybe don't need anything more than the economic security of what the Abacus validator set can provide. In either case, I think, again, the main difference is that we see Layer0 somewhat as a framework for how to do cross-chain communication, whereas we see Abacus as, I guess, a kind of prescriptive, a little bit more prescriptive in what the security model that you're signing up for looks like. And we see that as a good thing, not a bad thing, because cross-chain security is really the heart and soul of this entire space, right? That's like the most important problem I think that you could possibly be solving when you're building a cross-chain communication protocol.
Yeah, as Asa said, right, this is really the hardest thing about this, because these chains don't know anything about the outside world, and they take whatever the Oracle is going to give them, they take that as given. We talk a lot about interoperability, but at its core, it's just a different manifestation of the Oracle problem, which a lot of people are much more familiar with, but tend to not think of in this context. And really, the protocol that enables Abacus, what Axelar is trying to do with their network, these are all attempts to solve the Oracle problem for this specific use case. So you can think of with Abacus having two parts, right? The developer-facing part, which is all the tooling we're building, the example apps, and then you could think of another part being the protocol, right? The stuff that makes the magic happen. That is just a narrowly scoped Oracle network that is solely built for this purpose of relaying messages between chains. And we really think it's important. And if you think of what are we trying to do? We're trying to create a network that delivers a very nice experience to a developer. And this experience is about delivering shared state between the different manifestations of their app. And if the network didn't own this part, we wouldn't be able to define a key set of parameters. Your latency, the security, all these things are going to basically be defined by this plugin. And in our case, the plugin is part of the network. And in this other case, it doesn't have to be. And so we think that's a key difference, one that really matters to us, because we don't want our developers to think about anything more than their app. They're good at doing what they're doing. They don't need to be good at understanding how to communicate between two chains. And so that goes back to that core principle of keeping it simple. And we think this allows us to keep the system very simple for them.
And very pragmatically, which blockchains will Abacus support? Or which ones won't it support? I guess maybe that's a simpler question.
Oh, good question. So there's many more that it won't support than will support, unfortunately. But that's just a function of just how many chains there are these days. To start, we are going to have support for the more popular EVM chains. So by the time this pod will be released, we'll probably already be live on most EVM testnets. That includes the Avalanche C chain. That includes Polygon. It also includes Arbitrum and Optimism. Probably will include Aurora. About a list of about 8 of them. And we've started that deployment a number of days ago. And so again, I expect that by the time the audience gets this, it'll already be live. And we'll have those same EVM mainnets up by, let's call it conservatively, early July. And so those are what we're going to start with. Now, we think of the universe in forms of different virtual machines, right? Like, where does activity happen via VM? So clearly, the EVM is leading the pack right now. So from a pragmatic perspective, it just makes sense to focus on the EVM. What's runner-up? Well, it seems like the Cosmos universe. Of course, we include Terra in that. That's a pretty clear second, and they have Solana right on their heels. Now, what seems to be happening is that as others recognize the inertia and strength of the EVM, and look, we all know it's not perfect. We all know it's probably not the best from a technological perspective, but to the extent that there are network effects in some of these things, it's pretty clear the EVM has a pretty strong one. And what we're seeing is a motion by most layer ones, especially ones that are not EVM native, to add, we sometimes think of them as docking stations or like these ports with EVM support. So you're seeing what Neon Labs is doing on Solana, Evmos on Cosmos, Aurora on Near, Moonbeam on Polkadot, and in the substrate world. So if those all happen and they're stable, then great. We don't have to do much, and that allows us to keep up this consistent, simple developer experience. Because we'll put our mailboxes, right? If you remember from the architecture, Abacus just needs to deploy its mailboxes on each chain it wants to support. And you can imagine mailboxes on whatever Neon ends up building, mailboxes on Evmos, mailboxes on Aurora, mailboxes on Moonbeam, and every other EVM port city that we get to see. That's in the amazing case. If that happens, you should see us live on all of those. No more than a few months after we're live on that first set of mainnets. So,
what are the prospects for getting yield Bitcoin? Or would that have to be through sort of a wrap Bitcoin?
That is so the wrap Bitcoin part, that'll certainly be enabled very easily, because once we exist anywhere where WBTC or any form of wrap Bitcoin already exists, no problem. But getting what you'd consider native support, that might be, we're gonna need some way for the mailboxes to be deployed on Bitcoin, which won't be a trivial task.
Right.
Yeah. In the absence of kind of Turing complete scripting language on Bitcoin, that would require architectural changes. Yeah, we're comfortable with this because, again, we're focused on application-centric interoperability. And so from that perspective, the thing that's most important to connect are platforms for building applications. In terms of, BTC, the asset, and moving that from place to place, there are already a number of kind of purpose-built Bitcoin bridges, and we think they're great. Well, sorry, that's a very broad statement.
Some of them are great.
Yeah. I think it's great that there is so much effort and investment into developing kind of Bitcoin-specific bridging technology, and for the most part, that's not a game that we're interested in, getting involved with ourselves.
Yeah. So what you could see, Nick, is down the line maybe deploying mailboxes on RSK, maybe deploying mailboxes on stacks, right? As soon as it seems like there's actual demand for them, we're going to be there, right? But hopefully it's become evident by now that we operate with a big sense of pragmatism, and we just want to serve, like, we are not focused on our user beyond what our developers will want. So, like, this is first and foremost a developer product, and if they tell us, hey, we need you on RSK, we need you on stacks, we'll make every effort to be there.
Maybe the listeners are feeling inspired right now. Where do you direct them? What's their next task after listening to this episode?
So next task is definitely go to our docs, get smart about Abacus. Then you should go to the repo, and then you should test out with some of the example apps, whether it's if you want to do something real simple, maybe try ping pong, or if you're slightly more ambitious, it's just as simple, but you can try and create a natively multi-chain token. So give it a go, and then come to our Discord and let us know what are your questions. But that's what you'll be able to do, and you'll be able to actually touch this thing and experiment it and send messages across chain. You'll be able to create mind you, on testnet, you'll be able to make an app that shares state between these 7 or 8 chains. We think that's pretty cool. At its core, Abacus is about doing stuff you couldn't, and you're going to be able to do stuff you couldn't do before if you do this.
very concretely, our website is useabacus.network, and you can find a link to the documentation there, or you can go to docs.useabacus.network, and both of those will have links to our GitHub and to our Discord. It's funny. We've actually done. We're in talks with a number of projects, but we've actually done very little in the way of, I guess, anything that might be considered publicity. So not only is this, my first podcast personally, but this is actually the first outreach beyond kind of anything one-to-one within our personal networks that we've done.
Yeah, this is the Abacus coming out party.
Honored.
All that to say, SEO, might not be there yet, so you may have to plug in the URL directly.
Oh, that's okay. We'll put the links in the show notes. Well,
Perfect.
It's an honor to host you two. Thank you for joining us today, Asa, Jon. Appreciate it.
Thank you so much, Nick.
Well, thanks for having us, Nick.
Thanks, fellas.